In this lesson, we will establish a relation between value of the discriminant and nature of roots of the given quadratic equation. Since for quadratic equation, ax squared plus bx plus c equal to 0, the solution is given. The solution is x equal to minus b plus minus b square minus 4ac square root divided by 2a. This part of the expression inside the square root is called discriminant. So this part b square minus 4ac is called the discriminant and is mainly responsible for the nature of roots of the given quadratic equation. Because if we take case 1, for discriminant equal to b square minus 4ac equal to 0. If the value of this discriminant is equal to 0, this means x is equal to minus b plus minus 0 divided by 2a. So essentially the values of x are same. X is equal to minus b over 2a means values of x are same. So we say that roots of ax squared plus bx plus c equal to 0 are equal. So this illustrates that whenever the value of discriminant b square minus 4ac is equal to 0, then the roots of the given quadratic equation will be equal. However, case 2, if the value of discriminant b square minus 4ac is less than 0, then what happens that b square minus 4ac square root is equal to a negative number inside the square root, which is not real. So in this case roots are not real. Rather we say, so in this case roots are imaginary or complex. So third scenario is this, case 3, if discriminant, which is b square minus 4ac, is greater than 0. So if this is greater than 0, then this positive number inside the square root, which is b square minus 4ac, is a real number. And this generates real and distinct values. Of of x. Because this b square minus 4ac square root is a positive real number which once is added to minus b and one time it is subtracted. Therefore, it generates two distinct real numbers. But the interesting situation is, however, if b square minus 4ac is greater than 0 and is perfect square, then what will happen? Then square root will be cancelled with the square. Then square root is cancelled with square, generating a proper fraction. Generating a proper fraction. And in that case, roots are rational. So to say that if b square minus 4ac is a positive number and is at the same time is a perfect square, then the roots of the equation ax square plus bx plus c are not only real and distinct, but they are rational as well. And b part, if b square minus 4ac is greater than 0 but is not a perfect square, then obviously the square and square root will not cancel with each other. Therefore, there will be an irrational number in the part of the square root, resulting the overall roots of the quadratic equation ax square plus bx plus c equal to 0 being irrational. So if b square minus 4ac is greater than 0 but is not a perfect square, then roots of ax square plus bx plus c equal to 0 are real and distinct, but irrational. So these criteria should be always kept in mind while deciding the nature of roots. For example, the first question that is being asked is that for what value of m the roots of this equation, for what value of m the following equation have real roots. Here a is equal to what? A is equal to m plus 1, the given equation. So example number 1. Here a is equal to, so the given equation is m plus 1 x square plus 2 times m plus 3 m plus 3x plus c, which is 2m plus 3 plus 2m plus 3 equal to 0. And we want to prove for what value of m the roots. The question is, for what value of m the following equation have equal roots. So we will find that value of m for which the roots of this equation are equal. So comparing it with ax square plus bx plus c equal to 0, a is equal to m plus 1, b is equal to 2 times m plus 3 and c is equal to 2m plus 3. Now we'll first find the value of the discriminant. So the discriminant is equal to b square minus 4ac, which means 2 times m plus 3 whole square minus 4 times m plus 1 into 2m plus 3. This is the value of the discriminant. So this is equal to b square minus 4ac. And we'll continue to expand, and this will give us 4 into m square plus 6m plus 9 minus 4, and inside if we multiply, this will give us 2m square plus 3m plus 2m plus 3. And now if we take 4 as common, the inside will be m square plus 6m plus 9, 4 has gone out, minus 2m square minus 5m minus 3. And if we further simplify, this will become minus m square plus m plus 6. So this is the value of the discriminant b square minus 4ac. For roots to be equal, for roots of the given equation to be equal, we have b square minus 4ac equal to 0. If that is the case, this means 4 times minus m square plus m plus 6 is equal to 0. So this means that m square minus m minus 6 is equal to 0, dividing both sides by minus 4. Dividing by minus 4. So this will give us m square minus 3 minus 1 by factorization minus 6 equal to 0. M square minus 3m plus, and this is 2, plus 2m minus 6 equal to 0. So this gives us, if we take m common, m minus 3 plus 2 common, m minus 3 equal to 0. This means m minus 3 times m plus 2 is equal to 0. Therefore, m is equal to, so m is equal to, m minus 3 is equal to 0, or m plus 2 equal to 0. So m is equal to 3, or m is equal to minus 2. These are the two values of m which will give us two equal roots for the given equation.